Hi team, we're now starting section 3.2, quadratic functions. A couple reminders about quadratic equations. It is a second degree polynomial. That just means the highest exponent of a variable is going to be 2. The general form looks something like this. F of x equals ax squared plus bx plus c. If it is factorable, it might look something like this. F of x, that leading coefficient might be a GCF, so you could have a constant out in the front and then say, maybe x minus some constant n, or x minus some other constant r, if it's factorable. Then let's take a look at what a quadratic function may look like when you graph it. Remember, it forms a parabola. It could open up or down. But if we're looking at this graph, we have our intercepts of the equation. The x-intercepts are these points here on the x-axis where it crosses or intercepts with the x-axis. Your y-intercept is the point where it crosses or intercepts with the y-axis. Now, let's stop there with just the intercepts and focus on how to find those. Remember, with the y-intercept, sometimes that's also called the vertical intercept if they're using different variables. In order for a point to land on that y-axis, the x-coordinate has to be 0. So we would plug in 0 for our x and solve for our y. That would be our y-intercept. The x-intercept, which they may use the word 0 or root to find those values, then remember the y value has to be 0, and then we have to solve for the x. There's a few ways to find those x-intercepts. One way is to factor. And if we had, like we had up above, the x minus n, and we'll write x plus m, we set the function value equal to 0. And then remember, we said each of these factors that have an x in it equal to 0. And that would give us two solutions, x equals n and x equals the opposite of m. The second method is using the quadratic formula. So to use the quadratic formula, it has to be in the general form of the ax squared plus bx plus c. And we use all of those coefficients, and we would solve this formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c. All of that is in the numerator, and in the denominator, we get 2a. And there's also a completing the square, and we'll look at those kind of methods here in a second. Looking back at our graph, we have also the vertex. That's the point down here at the very tip of that parabola where it changes directions. And there's a couple of ways of finding that vertex. Now again, the vertex is going to be the maximum or minimum if it opens down of the graph. And we would call that point HK. To find the h value, if we have the function f of x equals ax squared plus bx plus c, in order to find h, we would take the opposite of b divided by 2a. And if you notice back over here with the quadratic formula, negative b over 2a, if we looked at just that value, that gives us the x-coordinate of the vertex. I call it the boot. So to find the vertex, we can use the boot of the quadratic formula. But then once we find h, we have to find k, And so k is going to be the function value once we plug in h. The last piece in this graph that I want to point out is that red dotted line that's going straight through the vertex. That's called the axis of symmetry. It's an imaginary line. You don't necessarily graph it, but it basically says that if you know a point on the left side of that symmetry, for example, if we were looking at this point way up here, the -2, 5, you would have a mirror image point on the other side of that axis of symmetry. In other words, the left point is 3 units away from the axis of symmetry, then you have a right point that is 3 units away from the axis of symmetry. That is true of any point on the parabola. So if you're trying to graph, you don't have to find every point to the left and to the right to get the full picture. You find one, you know where that vertex is, and you just find a matching point or a mirror image on the other side. So again, the axis of symmetry in words is a vertical line through the vertex. And so since it is a vertical line, it will always have the equation x equals, and in this case, since it's the vertex, it's going to be the h, or the x coordinate of the vertex, or x equals the opposite of b over 2a. Be sure you include the x equals. It's not just a number, it's a line. So you need the equation of a line. Must include the x equals. So we've talked about the general form and that you can factor that general form, but there's also what we call a standard form that is sometimes called the vertex form. And that is f of x equals a times x minus h squared plus k. Notice we are using the h and the k again. If it's in vertex form, then we can look at these two constants here and determine what our vertex is. A is the same a in the ax squared plus bx plus c. Is that leading coefficient the same? And again, h and k are the coordinates of the vertex. So notice how it looks like f of x equals x squared, but you have transformations. You have a vertical stretch, that's your a, you're multiplying the function by a, and you have a vertical shift of k, horizontal shifts dealing with your h. So if we know that this guy has a vertex at 0, 0, then we shift it h left or right and then k up or down, that's going to be your new vertex. So there are two ways to put a general form into the vertex form. So let's take a look at this example where we want to convert f of x equals 3x squared minus 12x plus 5 into the vertex form. The first method is completing the square. So we are going to factor out the a out of the first two terms. We're going to focus on these two and factor out that 3. So we get an x squared minus a 4x plus 5. Don't forget your parentheses. And the second thing we're going to do is take half of the x term coefficient and square it. Take half of the x term coefficient, -4, and we're going to square it. So 1/2 times a -4 gives us a -2. And then we take that -2 and square it, and we get a +4. The third thing that we do is we add this number inside the parenthesis and subtract the equivalent number. You might want to underline that, the equivalent number outside. So remember, we had 3 times x squared minus 4x plus 5. So we're going to add 4 inside that parenthesis. But notice when we add that 4 inside, we are technically adding a 12 because 3 times 4 is 12. So if we've just added 12 to this expression, we need to turn around and subtract 12 from that expression in order for it to remain equivalent to its earlier value. We factor the perfect square trinomial and combine like terms. So the 3 is still on the outside. We get a perfect square trinomial that will always factor into a binomial squared. And then 5 minus 12, so -7. This is a good method to practice because you're going to be using it later in the semester as well. A nice shortcut, though, or a way to kind of check your work is to use the fact that the h part of your vertex equals a -b over 2a. So again, if we're starting with the original function, f of x equals 3x squared minus 12x plus 5, we can label our a, our b, and our c. We can find our h, which is the opposite of our b, so the opposite of a -12 over 2 times our a, which is 3. That gives us 12 over 6, which is 2. And then to find our k, we plug that 2 into the original function. We get 3 times 2 squared minus 12 times 2 plus 5, which gives us a -7. Well, we have our h and we have our k. So if we remember this format of the vertex form, our a is the same a as the original, which was a 3. Our h is 2, so it's always the opposite inside, so -2, and the k is as is, -7. So we get the exact same function as we did on the first one. So here's some concept questions for quadratics to help you guys with some of the reading problems. Suppose a swimmer dives off a cliff and their height is represented by some quadratic function s of t in t seconds. Sometimes it helps to draw a picture. Okay, we're on a cliff and this person dives down into the water. So that kind of looks like a parabola. So when looking for their maximum height, here's some of the hints in those reading problems. The maximum height, what point are we looking for? So for the maximum height, we are looking for the vertex. But remember, the vertex has 2 coordinates. It has the h and the k, which in our case now is going to be a t and an s. T in seconds and s is their height. So if they're asking for the maximum height, which coordinate would answer the question? And that would be the s or k. In other words, you wouldn't give them the entire coordinate point. You would be looking for one of those values, either the input or the output. In this case, they want the output. For question 2, it says when looking for the height of the cliff, what point do we look for? And which coordinate would answer that question? So if we think of that picture that we drew above, but let's put it on a coordinate plane. Let's say they're at the edge of the cliff and they're diving off that cliff into the water. if we want the height of that cliff, we're actually looking for the y-intercept. And remember, the y-intercept is always of the point 0, y. So which coordinate would answer the question of that height? It would be the y. And then the last one, when looking for when they will hit the water, what point are we looking for? And which coordinate would answer that question? So again, if we were to draw him going off, or her, going off the cliff and hitting the water, what point are we looking for? Well, in this case, we are looking for the x-intercept. And that is always of the form x0. When looking for when they will hit the water, we have to pay attention to the wording. We're looking for when. So they're not looking for the height or how far away they are from the cliff, but they're looking for the time. So remember, if we're dealing with t and s, then we're looking for the coordinate t. We're looking for the time. Just like in problem 2, if this were a 0s, we're looking for the y or the s value. So let's practice a couple of examples, like writing a quadratic equation for a parabola that has a vertex and a y-intercept. Now, it didn't tell us what type of equation, whether we want it in standard form or general form. All we know is that we have the vertex, which means we have the h and the k, and we have some point. We have the y-intercept. Well, if we have the h and k, then that means it may be easier to use the vertex form, a times x minus h squared plus k. Let's plug in what we were given so far. Y equals a times x minus 2 squared plus 4. And remember, the only other value that we need now is the a. Wouldn't it be nice if we had values for the x and y that we could plug in so we could solve for the a? Hey, guess what? We do. We have an x and a y being given over here. It happens to be the y-intercept. They didn't have to give us the y-intercept. It could have been some random point. It works the same way. So let's plug in the 0, 16. And we would get 16 equals a times 0 minus 2 squared plus 4. So we get 16 equals negative 2 squared is 4, so that gives us a 4a plus 4. Subtract 4 from both sides. 12 equals 4a. And so we get an a equals a 3. So our quadratic equation is y equals 3 times x minus 2 squared plus 4. Now they want us to write a quadratic equation for a parabola with zeros. Remember, these are x-intercepts of negative 2 and 4, and then also has a y-intercept of 0, 2. Well, if they give us zeros, then it might be better to write them in factored form, where we have a, and it's basically x minus one of its zeros, x minus another 0, and so forth. So we plug in what we know, y equals a of x minus a negative 2 and x minus a positive 4. So that gives us a of x plus 2 and x minus 4. And again, we need to find this a. So we're going to plug in the 0, 2 and solve for our a. So 2 equals a, 0 plus 2, 0 minus 4. Then we have 2 times negative 4, which is a negative 8. Negative 8a. Divide both sides by negative 8, and that reduces to a negative 1/4 for our a. So our quadratic equation would be y equals negative 1/4 times x plus 2 times x minus 4. We don't need to expand these unless they ask us to. This is a quadratic equation. So in this next example, we want to find the intercepts, vertex, and axis of symmetry of the following quadratic equation. So let's take a look at our intercepts first. Remember, our y-intercept is always of the form where our x is 0. So we're going to plug in 0 everywhere there's an x. So f of 0. And that gives us a negative 1.5. So we have a y-intercept of 0, negative 1.5. Now, for the x-intercept, we need it of the form where our y is 0. So we have 0 equals 0.5x squared plus x minus 1.5. So we have a quadratic equal to 0. We have two choices here. We can either factor or we can use the quadratic formula. So I'm going to factor. So let's multiply both sides by 10 in order to get rid of that decimal. And at this point, we may not even be sure that it is factorable, but we do notice that there's at least a GCF. So we can take out a 5. And then we can factor that trinomial. Set both binomials equal to 0, and we get an x value of negative 3 and an x value of 1. So our two x-intercepts are negative 3, 0, and 1, 0. Now let's find the vertex. We always want to find the vertex before the axis of symmetry. So to find the x-coordinate of the vertex, or the h, remember we take negative b, or the opposite of b, over 2a, which will give us a negative 1. And then to find the k, we plug in that negative 1 into our function. So we get a negative 2 for our k. So that gives us a vertex of negative 1, negative 2. Now remember, for the axis of symmetry, it is always the full equation. You have to have the x equals, and it's the x coordinate of our vertex for the h. X equals negative 1. This one involves some critical thinking skills, so don't panic. If you're not quite there yet, it's easy to make mistakes. So let's read through the problem first. The unit price of an item affects its supply and demand. That is, if the unit price goes up, in other words, the consumer has to pay more money, the demand for the item will usually decrease. In other words, not as many people are going to want to buy it. So for example, a local newspaper currently has 84,000 subscribers at a quarterly charge of $30. Market research has suggested that if the owner raised the price to $32, they will lose 5,000 subscribers. Assuming that subscriptions are linearly related to the price, what price should the newspaper charge for quarterly subscription to maximize their revenue? Well, they've given us a few hints here in the reading. One of them is that it's linearly related. That means we're looking for a slope and a y-intercept. They're also asking us to maximize the revenue. So that means we probably have another equation other than a line, because a line won't have a maximum. It will keep going forever. Now, in order to figure out how to maximize revenue, we need to know what a revenue function is. So if you have a problem like this in your homework, go to Google, look it up. Revenue is all the money that comes in, okay, before you pay your bills and everything, just everything that comes in. So your revenue equals your price times the quantity you sell. Those are a couple of clues right there. So let's go back to the fact that the subscriptions are linearly related to the price. Linear, think y equals mx plus b. So we need to find our slope. In order to find our slope, we need 2 points. They actually gave us 2 points. They told us that we have 84 subscribers at a charge of $30, or at a price of $32, they will lose 5,000 subscribers. We first need to decide, let's take a look at that first point, the $30 and the 84,000 subscribers. Which one is going to be our input, the X, and which is going to be our output, the Y? Well, if they charge so much money, that affects how many subscribers they're going to have. They kind of gave us that hint in that second sentence. If the unit price goes up, the demand changes. So the demand is dependent upon the price. So we're going to do the price first and the number of subscribers second. Input, output. So for our 2 points, we have $30 gives us 84. So instead of putting in all of those zeros, we're just going to do it in thousands. So our X is going to be price, and our Y is going to be our quantity in thousands. Okay, so we'll kind of keep that handy. Now for our second point, they gave us a price of $32. But for $32, that does not mean we have 5,000 subscribers. Notice they say we lose 5,000 subscribers. Okay, so occasionally they'll throw in those little hints, those little details that we have to pay attention to. So our next value, that Y value, is not 5, but it's 84 minus 5. Okay, we lost 5,000 subscribers, so we actually have 79. So now we can find the slope. If we did 79 minus 84, 32 minus 30, we would get -5 over 2, or a -2.5. That means we lose 2,500 subscribers for every dollar increase in price. So now that we found our slope, let's go ahead and find our equation, y equals mx plus b. So we have y equals -2.5x plus b. To find that b, we need to plug in one of our points, x, y. We can use 3084. So if our y-intercept is 159, that gives us a linear relationship of -2.5x plus 159. Now remember, this y represents our quantity, the number of subscribers in thousands. The problem is we want to maximize revenue. This function does not represent revenue. Remember, revenue over here is price times quantity. So we're now going to write our revenue function. Going up there, we see that our price is represented by x, and our quantity is our y. So we're going to plug in the -2.5x plus 159, since that equals our y, or our quantity. When we distribute, we get -2.5x squared plus 159x. Now we have a quadratic. The leading coefficient is negative, so we know that it opens down. And we want to find the maximum revenue. That means we are looking for the vertex. So that's going to be our h, which again is the opposite of b over 2a. In this case, our b is the 159, because our c is 0, divided by 2 times a -2.5. And that gives us a 31.8. So again, they're asking us for the price that will maximize the revenue. We found the price. So they need to charge $31.80 quarterly to maximize revenue. All right, now I realize that you may be looking at this going, okay, some of that makes sense, but I never would have thought of it myself. That's okay, you may not be there yet, but that's where we're wanting you to get. If there's something you don't understand, you look it up, you try something. I did this a couple of times and I kept making mistakes, and then I would catch myself and then I'd have to go back. So don't beat yourself up and don't be afraid to be wrong. Try it, see where it leads you, and then you may go, oh, wait, I need to change this, okay? That's what we're growing towards, not just coming up with the right answer, but the process when you're faced with a problem that you've never seen before. So I hope you guys have a good week. Miss you. Talk to you soon. Bye.